Savannah. All right, so the directions for 7 and 9 wanted you to solve the equation by finding square roots. So you didn't need to complete the square for those problems. Instead, you had to try and get the left side to factor so that you have a parentheses squared, so that you could then take the square root of it. So if you look at the left side in number 7, we have x squared minus 2x plus 1/9. So if this is a special pattern that can factor into a quantity squared, what would that special pattern be? So how would it factor into that perfect square trinomial? Chelsea?
Minus 1/3 squared.
Yeah, so it's x minus 1/3, because the square root of 1/9, if you take the square root of top, the square root of the bottom, you get x minus 1/3. And then that's equal to 1. So with 7 and 9, you have to factor the left side first, and then it says to solve using square roots. So now that it's factored and it's a perfect square trinomial, we can take the square root of both sides. Chelsea, the square root of 1 is just 1. But we have a plus or minus in front of that one because we took the square root of two sides, or both sides there. And then when you take the 1/3 to the other side, you have 1/3 plus or minus 1. So that really means that you're taking 1/3 plus 1 and 1/3 minus 1. That's what the plus or minus means. So if you have those values and there's a plus or minus, it means that there are two answers. So 1/3 plus 1 is 4/3, and 1/3 minus 1 is negative 2/3. So factor the left side so that it's a perfect square trinomial. So that fits that pattern a minus b squared, taking the square root of the last number there. And then you're solving it by using the square roots. So number 9 was very similar, except there's a 9x squared and a 4. So taking the square root of the 9x squared would make it a 3, and the 4 would be a 2. So that would be 3x plus 2 in parentheses squared, and then you would take the square root of both sides. Other questions that you would like to go over? Katie. 29. 29 was definitely one that had fractions in it. Too many? So number 29, you have y equals 3x squared minus 9x plus 18. So the first step when you're completing the square is to take the c value to the other side. And then, Katie, what else would you do besides take the c value to the other side?
You do.
Before we can do b divided by 2, we have to do one thing before that. Yeah, we have to take the 3 out. So whatever coefficient is in front of x squared, that coefficient needs to be pulled out. So you can only factor or complete the square, not factor. You can only complete the square with the x squared term. It has to be by itself. So then if we take a 3 out, we end up with minus 3x. So b is negative 3. When you divide that by 2 and then square it, what's that make? Brandon? 9/4, because you're squaring the top, you're squaring the bottom. And then you're taking 9/4 times 3 to put the number on the other side. Now, when you multiply 3 times 9/4, this is really like having the fraction 3 over 1. So you're taking 3 times 9 and 1 times 4. So 3 times 9 is 27. 1 times 4 is 4. So you would be adding 27/4, which every other problem that we've done, when you multiply by this number here, it ends up canceling out the fraction and you add a nice number to the other side. So Josh, you have your calculator out. Can you take negative 18 plus 27/4, use the math frac, give me a fraction?
Mm-hmm. negative 45 over 4.
So negative 45 over 4. Thank you. So that's y minus negative 45 fourths. And then on the right side, if we put this into that perfect square factor, we would have x minus the square root of 9, the square root of 4 is 3 over 2. Essentially, you're going back to that b divided by 2. So in vertex form, it's 3 and then x minus 3 half squared. Taking the 45 fourths to the other side makes it a positive 45 fourths. Right.
In the vertex would be 3 halves and 45.
Right, so the vertex would be the h and the k. So the opposite of what's inside, pull it out, flip the side. So that's the 3 halves and then 45 fourths. So that question wanted you to get it in vertex form. So now that it's in vertex form, you can then identify the vertex. Other questions from the homework? Keisha, 21? So 21 says 3x squared plus 36x equals negative 42. So it's already, the c is already taken to the other side, so you don't need to do that. What would you do first, though, since the c is already taken to the other side? What would you have to do? Nina, do you know?
You take out the
Yeah, what is that? 3. So if we take out a 3, we get 12. And then what can you do with that 3, Nina? Because it's an equation.
divide it on the other side.
Yeah, so because this is an equation, we can now divide that value out. It's equal to 0, or was equal to negative 42. But when you're solving, you're allowed to then take that number out of the problem, and you have x squared plus 12x, because those 3's cancel. What's negative 42 divided by 3? Chelsea?
Negative 14.
Negative 14. So take the 3 out. Because it's an equation, you're allowed to get rid of it because you're trying to solve for x in this case. We're not keeping it in the standard or the vertex form for the parabola. So now we're taking b, which is 12, dividing it by 2 and squaring it. So that's 6 squared, which is 36. Add that 36 to the other side as well. So what you add to one side, you have to add to the other side. And now we have x plus 6 squared. Vernon?
Equals to plus or minus the square root of 22.
So that's equal to 22, and then take the square root. So you get plus or minus the square root of 22. So when you take the 6 to the other side, it's now negative 6, and then plus or minus the square root of 22. So 22 doesn't break down. There's not a 4 that goes into it, or 9. So it's just the negative 6 plus or minus the square root of 22. So those were 3 good ones because you got to see like one from each type of problem that we worked with. So that one was completely like completing the squares, solving for x. The last one we did was getting it in vertex form. The first one you were just solving by like getting it to factor. It was already in like the trinomial form, but we need to factor and then solve. Did the stapler make its way around? Does Ethan have the stapler?
Yes, he does.
I only use one paper.
So he felt that he would just keep it instead of passing
I
it.
didn't even notice it on my desk, to be honest.
What?
I didn't even notice it on my desk.
Way to go. It's
So we should blame it on Derek then.
Derek.
Derek.
No, I wouldn't blame Derek.
This is why
No,
you're-
blame the comp.
All right, so if you don't need a stapler, if you could pass your homework forward, please. And turn to page 33 in your packet.
I only have one game left. So please. Oh, come on. Guys, sorry. Yeah. Somebody
You don't
did
need
do it.
it.
Yeah.
Is that everybody or
I mean, this.
Everybody?
Yeah, on my way out. Come on, Katie. Use your brain. Sorry. You deal with the program. I could do
All right, so on page 33. Sorry, Julie. I'm sorry. So page 33, we're going to talk about the quadratic formula today, which some of you may know, which is great. If you don't, that's okay as well. It is really a very straightforward equation for you to use. I call it a plug and check problem because you have a formula, you literally plug numbers in, and it's very easy to get an answer. There are not multiple steps that you have to solve through. There's nothing that you have to distribute out. You won't really have to worry about trying to add a number to the left and the right. It really is just working with the formula and trying to solve for x. So the goal with the quadratic formula is for us to have another way to solve for x when the equation is in standard form. So the quadratic formula is a method used to solve a quadratic equation. And the quadratic equation that the quadratic formula works best for is when it's in standard form. So that ax squared plus bx plus c equals 0, gotta be equal to 0, would be when we would want to use the quadratic formula. So factoring is one way we can solve a quadratic in standard form if something's factorable. Another option would be to complete the square, which is what we've done the last couple of days, and then use the square root method. So those are other options that you can use. Or you could use the quadratic formula, and some people prefer just to use the quadratic formula to solve anything, and it works for any type of quadratic equation. You can always use the quadratic formula. Oh. Look, Nina.
We found it. Thank
She was
you.
looking for it. Thank you.
She's so happy. I'm so excited. I lost my history book last year too.
Oh.
It was almost like a
Miss Barnett would have killed you.
Oh, man.
I found
All right. So the other term underneath here is called a discriminant. And the discriminant, once we kind of look at that, that tells us how many solutions a problem has and the type of solution that they are. So how many solutions and the type. So when I talk about the type, is it a real solution or is it an imaginary? So do I end up with an imaginary number? Do we have one x-intercept or are there two x-intercepts? So that's what the discriminant will tell us. And I know it seems like a weird word, but you'll see that it's pretty straightforward. So this should be pretty straightforward, nothing crazy confusing going on. So the quadratic formula, did anybody have Mr. Warnock last year?
Yes.
Yeah. See, you guys know that
Oh, so
song.
you guys know the song?
Yeah, we
I
can
heard.
sing the song.
I know the
There's
song.
a
Yeah,
square
sounds
negative b plus minus square is b squared minus 4ac all over 2a.
Yeah,
Thank you, Nina.
She was really quick. Could you slow it down, like just a couple beats?
I learned that
Whisper.
song.
A b squared minus 4ac all over 2a.
So, need a sing it extremely
Yeah,
quickly.
you're a clown.
So x equals negative b. I did not borrow the little Jack in the Box from him to walk around and sing this crank the song out.
It was so scary.
I should have invited him to come down though.
No, I
Why
would
don't
shoot
you
myself.
No. Alright, so it's x equals, and once you use it like 3 times, you'll have it memorized by the end of the period easily. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you don't have the little jingle to the Jack in the Box in your head or the pop goes the weasel, that's okay. You'll use it a couple of times and you'll still have it memorized without the crazy song that makes you
Wanna shoot
Go
yourself
back.
in the face?
well,
One
not
of
that
these
much.
different types of wood
I
is
mean,
poplar.
I would go to that. I hate poplar.
You hate poplar.
Yeah, because it's like, it shreds, it like breaks super easy if you put like 2 pounds.
What?
Because of Pop Goes the Weasel?
Maybe.
Maybe.
What?
Alright, so this first problem says it's going to have 2 real solutions. So that means we should have 2 x values that are real. What would you do first to solve the problem, Chelsea?
Subtract 6.
Yeah, it needs to be equal to 0. So that's if you're factoring or if you're using the quadratic formula, it has to be equal to 0. So take the 6 to the other side. Set it equal to 0. Now, this problem does not factor because a negative 6 can never have 2 factors that multiply together to give us a positive 7. So it's not factorable. So we have to use the quadratic formula in order to solve it, or we could have completed the square like we did the last 3 days. But we'll try the quadratic formula. You might have a preference after you go through a couple of the problems. So again, the quadratic formula, just to write it up here so we can see it, negative b plus or minus, that plus or minus is there because of the square root, the parabola having a left and the right side of the axis of symmetry. So b squared minus 4ac all over 2a.
How'd they just come up with that?
I know, people are creative.
Right.
No.
People are math geniuses.
Yeah, math geniuses. So your a value is in front of x squared, your b value is in front of x, the c is the value without an x with it. And then literally, you're taking those 3 numbers and just plugging them in the spot where a, b, and c are in the equation. So b is 7, but it's supposed to be a negative b. And then the plus or minus. And then again, b squared, so 7 squared. The 4 is in the problem already. And then a is 1 and c is negative 6. On the bottom, we have 2 times a. Again, a is 1. So in your calculator, or in your wonderful capacity of the brain that you have there, all you're doing is plugging this stuff underneath. So you're going to keep the square root in the problem because we're not having decimal values. We're working with radical square roots, keeping those things exact. So you're really taking 7 squared, which is 49, and then we're subtracting 4 times 1 times negative 6, which makes negative 24. So we have 49 minus a negative 24, which is, so 49 minus negative 24, that's 73. Can that be broken down? Can 73 be broken down? No, it's prime. Only 1 times 73 makes 73.
That's terrible.
Terrible.
That's stupid.
So-
73.
This is the answer to your problem. You can't reduce 7 and 2 because 7 and 2 don't reduce. You don't need to separate it, but there are 2 solutions here. So this one solution is negative 7 plus the square root of 73 divided by 2. The second solution is negative 7 minus the square root of 73 divided by 2. But you'll never be asked to write them as separate solutions. So even though it looks like one answer, there's still 2 there because of that plus or minus thing. So we would have found the same answer if we completed the square. We would have gotten the exact same answer if we completed the square. We can't factor it because it's not factorable. So this is the only other way to solve it without just totally using the calculator.
That's ugly.
That's it. Questions? Alright, so if you look at the middle problem, this one tells you that there's going to be 1 real solution. So once we work through the problem, we should get 1 answer when you're done instead of 2 answers. So if you need to sing the little song in your head, I'm going to rewrite this again.
You guys only need to sing a song for you.
Let's get in the deepest voice
Can you?
again. Go.
Go.
Right
now.
We're ready.
He's like too happy about
This is torture.
All right, so we got 30. Even though it was a negative 30, it's then a negative b, plus or minus negative 30 squared. That's our b squared. Minus 4, a is 25, and c is 9. Squeeze that number in there. And then on the bottom, 2 times a, 2 times 25. So underneath the square root, Ethan, what's negative 30 squared? Without your calculator.
Okay, so I'm gonna guess.
What's
3
3?
squared is 9.
So 30 squared
30
is
would be 90. No, it would be 900.
900, right. So that's 900. And then Ethan, still using your brain, 4 times 25 is?
100.
100 times 9 is?
900.
So 900 minus 900 is?
0.
0.
Ooh.
That's it.
No calculator necessary. So we have 30 plus or minus the square root of 0, which is just 0. So essentially that part goes away. So you're left with 30 over 50, which is 3 over 5. So that one is a nice answer. You get 3/5 there. You get one answer.
I'm such a fan of this.
That one's
I'm
cute.
so proud.
You like this formula?
The quiz is so much better than Me too, I love it.
I'm so
I was to like solve for
I
A or
know.
something.
No solving for A.
I just really wanted that one.
Less of that.
All right, so just a reason why there's only one x-intercept. There's one x-intercept because the vertex, this is supposed to cross my x-axis, I kind of just missed. The vertex crosses the x-axis one time, or touches the x-axis one time. So that one x-intercept is also the vertex of the parabola. It doesn't cross through it. So once it crosses through, then you have the two x-intercepts, or your two answers. But if it's only touching it at its vertex, there's just that one solution. So that's why the one solution is working. So you can kind of have like a graphical picture or reason why. So the last one on this page says they're going to have imaginary solutions. So that means we're going to have an I in the answer. And Audrey, what do you have to do first to solve this one?
-5.
Yeah, take the 5 to the other side. And then you're still using negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is 2, it's negative 2 plus or minus 2 squared minus 4 times negative 1 times negative 5. And then on the bottom, 2 times negative 1. So underneath the square root, try and like do mental math here. Don't rely on that calculator all the time. So 2 squared is 4, and then you have 4 times negative 1 times negative 5. So Julia, we're subtracting 4 minus what?
-1.
Yes. Say it again.
4 minus -1.
4. What's 4 times negative 1 times negative 5?
-20.
Negative 20. So 4 minus 20 is
-16.
negative 16. So this is 4, and then a negative 20. And 4 minus 20 is negative 16. What is the square root of negative 16? Okay?
The I square root of 16
So it would be-
goes to 4i.
Very nice. So it would be I square root of 16, which she said goes to become 4i. And then it's divided by 2. Can that be reduced any further? Can we simplify that?
Yes.
Yeah. So when you simplify it, like you have to do like a little crisscross. This 2 has to simplify both numbers on top because both numbers are divided by 2. So when you simplify it, you got to crisscross. So Luke, negative 2 divided by negative 2, that should be a negative down there. Negative 2 divided by negative 2 is?
A positive 1.
And then the other, that was my here's my cross. 4i divided by negative 2 is? negative 2i. But because the plus or minus is already there, you're not going to put plus or minus a negative 2i. Like that plus or minus is already in there. And you're not going to flip it to be minus plus. So it's 1 plus or minus 2i. So when you're simplifying, make sure you crisscross, do both of them. Questions? All right, so on the back, we're going to look at the discriminant, which just pretty much tells you how many solutions you have. So you don't have to do anything different for the discriminant. It's part of the equation. The discriminant is the b squared minus 4a part. AC, I should say. That's the discriminant. So essentially, the number underneath the square root is called the discriminant. What the discriminant does is it tells us how many solutions you'll have and the type of solution that you'll have. So without looking at the graph, by just calculating the discriminant, if it's greater than 0, which was like example 1, we have the square root of 73, then I will have 2 real solutions because those 2 solutions are the x-intercepts of the graph. The graph crosses through the x-axis so that the vertex is below it or maybe it's above it, but the graph is crossing over the x-axis, the left and the right side of the parabola. When it's equal to 0, so that was like number 2 that we just did, you get 1 solution because the vertex is the x-intercept. So it stops at the x-axis and it kind of curves in the other way. It doesn't go through. And then the one we just did was the imaginary solutions. When you have an imaginary number, it doesn't graph on your xy graph because technically they're not there. They are imaginary. The only ones that we graph are the real ones. But the reason that it correlates with your graph is because this is the parabola that doesn't go below the x-axis. That's why they're imaginary solutions. So there aren't any solutions because there aren't any x-intercepts of the graph. It's not crossing through the x-axis. So when it's less than 0, it says you're going to have 2 imaginary solutions, or it would say that you shouldn't have any x-intercepts. So if we did try and find the x-intercepts, they wouldn't be there. They wouldn't exist. Questions with that? So down below, there are 3 problems. But then underneath those 3 problems are like a little chart that goes with those 3 problems. And it kind of like separates the discriminant so we can calculate it, and then finding the actual solutions. So if you want to use the space above, you can, but I'm just going to use the little space below. You don't need that much. But we're going to calculate the discriminant first and determine how many solutions there will be, and then we'll use the discriminant to find the solution, because the discriminant is part of the equation. So our first one says x squared plus 6x plus 5 equals 0. So to find the discriminant, we're taking b, which is 6, you're squaring it. So this is just the little part underneath the square root. Minus 4, a is 1, and c is 5. So we're using this problem right here. So I'm taking the numbers from this problem. A is 1, b is 6, c is 5. And I'm just plugging them down below. So if we calculate that, 6 squared minus 4 times 1 times 5 is, Brandon?
36 minus 20,
Which is
greater than 0.
which is 16. 16 is greater than 0, so that tells us that we will have 2 real solutions. So the discriminant is greater than 0, so we should have 2 answers to our problem, 2 solutions. To find those solutions, now that you have the discriminant, you're just using that in the quadratic formula, because it really is part of the quadratic formula. So negative b, well, b was 6, because it's 6 squared, so it's negative 6, plus or minus. The square root of my discriminant is 16, and then 2 times a, or 2 times 1. So I'm still doing the quadratic formula, but I just used the discriminant and actually plug that in, because we already calculated it. Why calculate it again or a second time? So Ethan, the square root of 16 is? 4. So we have negative 6 plus or minus 4, and then divided by 2. So Ethan, if we actually simplify this, what's negative 6 plus 4?
Negative 3.
And divide it by 2, and you get?
Negative 1.
Negative 1. And then one more time, Ethan, negative 6 minus 4 is?
Negative 9.
Divided by 2
Negative 5.
is negative 5. So right there are my 2 solutions. So that plus or minus is saying you've got negative 6 plus 4 get that answer, and then cut it in half. Negative 6 minus 4, take that answer, cut it in half. We have two real solutions of negative 1 and negative 5. Those are the x-intercepts. They cross the x-axis, that's where the graph crosses the x-axis, or when the y is 0. So these are my two x values for the equation. So we either solved it or we found the x-intercepts, depending which way you want to think about it. So if you look at the second problem, it's x squared plus 6x plus 9. See if you can find the discriminant, and then use that discriminant to find the solutions. So take notice, the only thing that's changing is the c. So the goal is here to kind of see, like, how does that c change our values? So what's the discriminant? Julia?
0.
0. So how many solutions would we have if it's 0? 1, yeah. So we will have one real solution. So Julia, it looks like we just have negative 6 divided by 2, which is negative 3. So our real solution is negative 3. So after you find the discriminant, you're just plugging it into the quadratic formula because that's your value underneath the square root. So we have negative 6 plus or minus the square root of 0, and then divided by 2.
Gotcha.
So the last one, in part C, is x squared plus 6x plus 13. So c squared minus 4 times a, or b squared minus 4 times a times c. Anyone know what that number is? Brandon?
Or negative 16.
Negative 16. So what does that tell you about your solutions, Brandon?
There are two imaginary solutions.
Right, so this would be 2 imaginary solutions. And again, to find those solutions, you're taking negative b plus or minus the number we just found goes underneath our square root. So plus or minus the square root of negative 16, and then 2 times 1. What did we say the square root of negative 16 was?
4.
4i, and then divided by 2. So because there's an I in the problem, this is where we do that crisscross to reduce it. So Brandon, negative 6 divided by 2 is,
Negative 3.
and then 4i divided by 2 is
2i.
2i. Good. Anyone have questions? So on your assignment sheet, your homework was 3 to 39 odd, and I thought that was way too many problems to do. 25 problems seemed like
Yeah.
excessive. So if you just do the multiples of 3 instead of the odds,
Whoops.
that'll take you down to like 13 or 14 problems instead of 25-ish. Not necessary to do all of those. So mark that down on your assignment sheet. You're doing multiples of 3. 52 to 54 are 3 graphs that are already given. You're just saying what the discriminant would be based off of what the graph looks like. So if it crosses the x-axis twice, the discriminant is greater than 0. You're not doing any solving for those. And then 69 is a word problem, and it's just one little word problem that you'll use the quadratic formula for. It should be very straightforward. There's nothing confusing about the word problem.